Good morning, everyone. Welcome to the Seattle Aquarium. My name is Katie, and I'm an educator here. Now, did you know that the Seattle Aquarium has solar panels on our roof? If you look in the video behind me here, you can see the installation of those solar panels taking place over the course of several weeks. And right here in the middle of the screen, you can see that the appearance of our roof is slowly changing as each panel is added to the array. We took this action for the health of our ocean by participating in a community solar program with our local energy company. Now, you might be thinking, wait a minute, what do solar panels have to do with the health of the ocean? Well, scientists have discovered that burning fossil fuels for energy, like coal, oil, and natural gas, causes a serious problem called ocean acidification. So, has anybody heard of ocean acidification? It might be new for many of us, but now that we know about this problem, as concerned citizens, we have a responsibility to be a part of the solution for the future generations and the health of the ocean. Now, this next image shows many ways in which this fossil fuel energy system has helped to connect people around the world. So you can see the green, blue, and red lines, which represent land, sea, and air transportation routes around our planet. Burning fossil fuels has helped us move around our planet, power the places that we live and work, and create global connections that support our modern lifestyle. So there's no doubt that this energy system has done a lot of good, but it's also created rampant carbon dioxide accumulation in our atmosphere. Now, what does that mean, rampant carbon dioxide? Well, some carbon dioxide, or CO2, is needed for life processes, but it's not just something that plants breathe in and we breathe out. It's also something that gets put into our atmosphere anytime we burn fossil fuels. And these activities are putting a lot of CO2 into the atmosphere. You can see that in the image on the screen behind me as the cloud forms around the Earth. That cloud represents the accumulation of carbon dioxide in our atmosphere. Now, carbon dioxide is actually invisible, so this video is just a way of representing what we otherwise would not be able to see. Now, let's look at another video. This one shows that not all of that carbon dioxide stays in the air. Some of it is absorbed by the ocean. And we can see that happening in this video. And as that excess carbon dioxide, which we can see here in the atmosphere, is then absorbed into the ocean, it reacts with seawater, changing the ocean's chemistry. And this is the process that we refer to when we say ocean acidification. Now, how do we know that this is happening? Well, here at the Seattle Aquarium, we're working with NOAA, the National Oceanic and Atmospheric Administration, to monitor carbon dioxide in the atmosphere and in the ocean. So in this graph, you can see some of the data from one of NOAA's Seattle monitoring stations, and you can see that the higher spikes correspond to times of day when more cars are on the road burning fossil fuels for transportation. Now, ocean acidification has been well documented over many decades and by hundreds of researchers and has been linked to fossil fuel combustion from human activities. Many marine species that live here in the Pacific Northwest are already being affected by ocean acidification. Studies of the native Olympia oyster, for example, show that survival and growth decrease with exposure to ocean acidification in both laboratory and field settings, and the same appears to be true for many other species, including the pteropod, which is this guy here, a little swimming snail, also for red sea urchins, northern abalone, and turbid snails. So does anybody know what all of these animals have in common? That's right, they all have a hard shell. And you may even have seen other animals, perhaps even touch them gently with your science finger, that have hard shells in our tide pools at the aquarium today. So let's see how this is affecting these animals. If we think of an animal like a snail building a shell, like someone building a brick home, we can see here that each colored piece represents calcium carbonate, the essential molecule or brick that these animals use to construct their homes. Ocean acidification reduces the amount of these building materials that are available to animals in the ocean. So while our snail is stacking those bricks, it's like some of them are being taken away. This makes it harder for the snail to build its shell, and the shell becomes weaker. And that makes it harder for the animal inside to survive. And we are already seeing these effects right here in the Pacific Northwest, as well as in many other places around the world. Now let's take a look a little bit closer. This is a microscope image that shows what we just saw in the video. So you can see that the pteropod shell on the right, which has been exposed to ocean acidification, is weaker and has visible damage, which again will make it harder for the animal inside to survive. Now, So we know what ocean acidification is. We can see what its impacts are on some of these animals. But the next question is, how widespread is this problem? In this video, you're going to see a representation of how the invisible chemistry of the ocean is changing. Right now we can see blue areas, which show where there is plenty of calcium carbonate for animals to build their shells. But as time passes and the chemistry of the ocean changes with the addition of carbon dioxide, the color changes from blue to orange, showing that there is no longer enough calcium carbonate. The loss of these organisms affects the whole ecosystem, and we are all also connected to that ecosystem. You can see here how shell-building animals like pteropods are connected to other organisms within this ecosystem. If these animals struggle to survive, it could cause shifts in the ocean food web, which in turn can cause changes to the global food web system, of which we are all a part as well. So we don't want to wait to see how bad this gets. We have to take logical steps now to ensure the health of our ocean for the future. As we've already seen, humans are amazing innovators. We created an energy system that improved our lives, but that we now know is causing major problems in our ocean. And the key to getting our ocean back to functioning the way it should is to move away from fossil fuels for energy. So what actions can we take that will really make a difference? Well, fortunately, we innovative humans have already come up with other energy systems that don't rely on fossil fuels, systems like wind, wave, solar, and geothermal energy. Our next challenge is to implement these systems on a large scale, replacing our fossil fuel energy system with one that will provide us with the same power, but without the negative impacts of rampant CO2. So we need to change our actions, not just at the individual level, but at the city, state, and even the national level. The more people who take action to tell our energy companies and governments that renewable energy is important to us, the more likely it is that we will see large-scale shifts toward a system where renewable energy is the key instead of fossil fuels. That is why the Seattle Aquarium decided to install our solar panels as part of that community solar program. It allows us to share the energy generated by our array with others in the community, and also demonstrates that solar power is a viable way to power our lives and that these systems already exist. We've created a system that provides us with great power, but with great power comes great responsibility. In this case, the responsibility to replace fossil fuels with renewable energy sources to ensure a healthy ocean and a healthy planet for our future. And that is how the solar panels on our roof are connected to the ocean beneath us. Thank you so much for joining us today. If you have any questions about ocean acidification or renewable energy systems, please let me know. I'm happy to chat, and enjoy the rest of your day here at the Seattle Aquarium.